Let's take a look at the concept now of static variables. This is another keyword, another modifier to our definition and declarations that change how a variable is seen. And we know that's called its scope. If you make an external variable a static, so you say let's static int x, and to make an external, you put that outside any function definition. A static external will only be seen by its source file. None of the other files will get to see it. If there are multiple externals, and one is static and one is not, they will stay away from each other because they will actually be different places in memory. The static external in a source file will only be visible within that source file. Now, a static local variable, that's a static that's inside a function, will maintain its value. Remember we said automatics, if you make an automatic inside a function, whenever you come to that function, that automatic will be recreated. It will occur again because it's occurring on the stack inside the computer, inside the compiler. A static local variable gets put on the heap, not on the stack, so that it will stay around. Now, if you're not familiar with stacks and heaps and all that, that's okay. Just know that they are different places in memory, and they're set up differently. Let me break out of PowerPoint here for a second so that we can go and look at some code. Here is a little function called funcs.c, and that has our main in it. So here we'll drop it down, and here's what's going on. Here we reference func1, 2, and 3. We have to declare them out here so that main understands that they exist in another source file. They don't exist here. So those are just external declarations of func1, 2, and 3. Here we're saying that there are some external integers, variables 1, 2, and 3, that exist someplace else outside this source file. Here is another external which is being declared and defined right here, int VM, that's the variable that's in main, and it's equal to 0. Here, these are just declarations, not definitions. We're declaring that we will use these external integers someplace else. Let's take a look here. This is func1.c, which is another little function, and it has the extern int VM, v2, and v3, because VM is defined in main over here in funcs.c, and it is declared over here in func1.c. Extern int, these are declarations. This is a definition. We're defining v1 and setting it equal to 1 when it's first defined. This is a compile time event, not a runtime event, and I'll prove that to you in just a minute. Honest. Here's func1, and it has a static integer fv1, and this is function variable 1. We're not going to do anything with it. I just wanted to, as an aside, show you what a static local looks like. And anything that was done in fv1 down inside here would stay, so that if we are in main, we come to func1 or 2 or 3, when we get back to func1, it would still maintain the last value in fv1, whatever was in there, because it's noted as a static. Now here's func2, another pretty simple little file, and it has these declarations, extern ints, VM, v1, and v3, and it defines v2, and then we're going to print out what their values are. That's the same thing we do here. We print out, we're in function 1, and here's the value of VM, v1, v2, and v3, and there they are. This wraps around a little bit, so let me drag that so you can see it. Well, it doesn't want to come over, but anyway, v2 and v3. Same thing in func2, same thing in func3, external declarations, one definition, and all of these have been saved to disk. So let's compile them, and this is what it looks like. Compile and link, funcs, func1, func2, and func3.c. We just list the names in order of compilation and hit enter, and the compiler comes along, generates all the code, the object files, then the linker, incremental linker picks it up, and it's going to create funcs.exe because it uses the first C source file name. for its executable, and there's funcs and 1, 2, and 3 objects are all linked together, and all of these references tie these files together. Now, if we run funcs, we'll see what happens. When we're in main, we start out, and VM, that's this one here, this you can see it just in the corner, VM equals 0. It is 0, but look at this, V1 is 1, V2 is 2, and V3 is equal to 3. We have not yet come down through this part of the code and done anything. We're at this first printf right here in main, right there. So these functions have not been called yet, but the external variables that were created, like V3, already has its value because its value was set in memory when these things were created and initialized. They were set up at compile time, not at runtime. So they already have values. Then function 1 comes along, and here we see what the values are, and they're starting to increment because I'm doing that over here. Here in main, I increment V1 before I call function 1. So there we see in function 1, V1 is equal to 2. Because it started out as 1, I incremented it, made the call, then I increment V2 here in main, and I call function 2. So function 2 is going to print out F2. V1 is still equal to 2, and it's defined over there in the other function, in function 1, but it's still equal to 2. It hasn't changed or gone away. V2 is now equal to 3 because it's jumped up 1. V3 is still 3, and over here we're going to increment V3, and now it will be equal to 4 because they all had their initial values set, 0, 1, 2, and 3, and then they each incremented as they were supposed to, just like this. But the important thing to remember, and what we're talking about here, is the externals, the way they're declared, the way they're defined, and that they can be referenced across all different source files, even though they were originally defined in other source files. It's all of this linkage that we have done with these keywords and with the static keyword to make these work properly.